Here are the solutions for the page 11-12 transformations quiz. I'm going to start with the B version. I'm going to do the B, C, and D version, not the A version, because the A version is kind of easy. So let's start with the B version. So the equation looks like this, and whenever we want to find interpret a transformation, I like to put it in this form here. Okay, if I put it in this form here, then I can see easily what each element does, and you're going to have to like figure out your own way of memorizing what's the role of each one of these. The A here is a vertical stretch. The D here is a vertical translation. The C here is a horizontal translation, and the B here is a horizontal stretch. Okay? Whenever you have a stretch, if the parameter A or B gets bigger, that means it stretches longer, and then if it's below 1, A or B, I mean, then you're going to end up not with a stretch, but with a compression. Okay? Whenever you have a positive vertical translation or horizontal translation, that means it moves to the right or up. And if it's a negative C or D, then it moves left or down. Okay? One of the things I think makes it easier to remember these is that the translations are addition or subtraction, and the stretches are multiplication or division. And the horizontal translation and stretches are inside the parentheses of the function f, and the vertical stretch and the vertical translation are outside of the parentheses of the function f. Okay? Okay, so let's do our example. First of all, our example is not exactly in this form. To make it in this form, I am going to change this 0.5x here. I'm going to change it to 1/2 x, right? And if I change it to 1/2 x, I can also write it as x divided by 2, and then it looks more like x over b, right? So if I do that, I'm going to put x over 2 plus 1. If I do that, then I know that the b value is 2. The a value is 2. And the C value, which is the horizontal translation, is 1. Okay? So if I know that the vertical stretch is 2 and the horizontal stretch is 2, and I know that the horizontal translation is 1 to the right, then I can easily modify this drawing so that it becomes a translated version of the drawing. First of all, make sure that you do everything in the right order. And the order that you should do it in is this first, this second, this third, and this fourth. Okay? We can talk about this later about why you do it in this order, but if you do it in this order, everything's going to come out fine. Okay? Now, of course, if there's no C value, then you don't need to do that first. You would do the horizontal stretch first. Okay, so let's see what we got here. So in this case, we would do this first, we would do this second, we would do this third, and then we don't have a vertical translation. Okay, so first thing we're going to do is we're going to do the +1 horizontal translation. Remember, the +1 horizontal translation is actually a -(-1), right? Because the standard form has a negative here, or minus here, so it's going to be -(-1), which means we're going to turn to the left. Oops, I messed up there. Did you see that? I wrote +1 there. It's very easy to get confused there. We're actually going to move to the left, okay? So the first thing we're going to do is we're going to move every single point to the left. So this point moves to the left, 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 and this point moves to the left. Now I'm going to draw my new points with my red pen. So I got those 2 points, I got this point, and I got this point, and this point. And then I'm going to connect it and make my new drawing. Okay? And then the next step is number 2, which is to do a vertical or a horizontal stretch by a factor of 2. Okay? So if I'm going to do a horizontal stretch by a factor of 2, then I will be taking every single point and moving it twice as far from this y-axis. Okay? Since this point is already on the y-axis, we don't need to move it. It's on the y-axis, so doubling the distance from the y-axis is still 0. Okay? What about this point here? This point here is 2 units away from the y-axis, so we're going to multiply that by 2. We're going to move it to 4 units away from the y-axis. Okay? This point here is 1 unit away from the y-axis, and we want to double it, so it's going to go to 2 units away from the y-axis. This point here is 2 units away from the y-axis. We want to double it, so it's going to be 4 units away from the y-axis. And finally, this point here is 4 units away from the y-axis, so we're going to move it 8 units away from the y-axis, which is like totally off the screen. Okay? So I'm going to draw the new points here. So one of the points is here. One of the points is here. And so we're connecting those. And then one of the points is still on that y-axis. Okay? And the other point is here and here. Okay. So now we've done the second step, which is we've made it wider by a factor of 2. Okay. The last thing we're going to do is we're going to do a vertical stretch by a factor of 2, which means all the points that I've drawn in green here are going to become twice as far away from the point or from the x-axis. So here's the x-axis. We're going to make everything twice as far away from this axis. So this point is 1 unit away from the x-axis. I'm going to move it double away. So it's going to be 2 units away from the x-axis. This point here is 2 units away from the x-axis. So I'm going to make it 4 units away from the x-axis. This point here, which is on the x-axis, is 2 units away from the y-axis. I'm going to make it twice as far, 4 units away from the x-axis. And this point here is 3 units away from the x-axis. I'm going to make it 6 units away from the x-axis, because I'm doubling it, right? And same thing with this one, 6 units away. And so now I'm drawing the new shape. And now I'm done. Okay? All right. Going to letter C. Okay. So first thing we want to do is we want to put C in the standard form. And if we look at C, it is pretty much in standard form, except look at this. We need to have x divided by b as the standard form, right? I'm gonna rewrite the standard form here. F or AF of x divided by b minus c plus d. Okay, and so the 2 needs to be in the denominator. So instead of 2, I'm going to put 1/2 on the bottom. Okay, which you could also think of as 0.5. Maybe that's easier for you to do. So instead of 2 on top, I'm going to put 0.5 on the bottom. Then you notice that there is no c value, right? There's no c value there. And then the d value is minus 2. Okay? So first thing we're going to do is we're going to do the c horizontal translation, but there's no c value, so there's no horizontal translation necessary. Then we're going to do a horizontal compression by a factor of 0.5. So everything is going to become half as far away from the y-axis. Right now the y-axis is here. This point here is 1 away from the y-axis, so I'm actually going to move it halfway closer. This point here is 3 units away, So I'm going to make it half as close, so it's at 1.5 units away from the y-axis. This point here is going to become at -1/2 because half the distance from the y-axis. And then this one here is currently 3 units away from the y-axis. I'm going to make it 1.5 away from the y-axis, okay? So my new drawing looks like, oops, and this point here, of course, goes to here, right? It's 2 units away from the y-axis. I'm going to make it 1 unit away from the y-axis. So here's my new drawing, okay? So I just did the first step, which was to divide by 0.5. Next step is to do the vertical stretch by a factor of 2. So if I'm going to do the vertical stretch by a factor of 2, I am going to take each point and double its distance from the x-axis. So like for example, this point here is 1 unit away from the x-axis. I'm going to make it 2 units away from the x-axis. This point here is 2 units away from the x-axis. I'm going to put it 4 units away from the x-axis. And so on, okay? So for example, this unit here, it's 3 away from the x-axis. I'm going to make it 6 away from the x-axis. And, actually, it's the unit, it's here. It's like at -1/2, right? So I'm going to put 1 there, and I'm going to put 1 there because I've moved everything twice as far away from the x-axis. And now I'm just going to draw my shape here. Oops. It actually needs to go down all the way to here, right? All right. Now I'm going to do the final translation, which is a vertical translation by 2, and of course it's going down because it's -2. So now I'm going to take this green shape and I'm going to move all the points of the green shape down 2. So let's see, this point here is going to go down to here, down 2. This one here, down 2 also. This one here, down 2. This one here, down 2. And this one here, down 2. And I think I'm okay now. All right, so the brown shape is our final shape. Okay, we just did that with the brown shape. All right, now let's move to the last one. Version D. So this one is almost in standard form also. Remember the standard form looks like this. AF of x divided by b minus c plus d. So let's see. The a value does not exist, right? The a value would be 1. The b value looks a little funny here. The 2 is in the numerator instead of the denominator. So how do we adjust that? Instead of 2 in the numerator, we're going to put 0.5 in the denominator. Okay, so we're going to rewrite this like that. The plus 2 is the c value, except for we need to put minus something. So we're going to say minus a -2. Okay? And then the d value is just there. So the d value is d, the c value is -2, and the b value is 0.5. So that means that we know that in the horizontal direction, there is a compression by a factor of 0.5. There is a horizontal translation to the left by 2 units, and there is a vertical translation up by 2 units. Okay? And so let's see. First, I'm going to draw a picture of the horizontal compression by a factor of 0.5. And to do that, what I'm going to, the first thing I need to do, of course, is the c value, right? So the c value is going to be a shift to the left by 2. So this is going to go to here, 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 and this is going to go to here. So it's basically going to look like that, right? Okay. Next step is now I'm going to do the compression, the horizontal compression by a factor of 1/2. So all these points are going to be twice as close to the y-axis as they were originally. And of course this point was on the y-axis, so you don't need to move it. You see it got narrower. This point here is 3 units away from the y-axis, so we're going to put it at 1.5. And finally, this point here, which is 5 units away from the y-axis, we're going to put that at a halfway into. It's going to be at -2.5, which is here. Okay? So there is our next transformation, which was this one here, the V transformation, where I made everything half as far away from the y-axis because it's a horizontal compression. Last of all, I'm going to do a vertical translation up with the D value. And so to do that, I'm going to take every single one of these orange points and move it up 2 units, 2, 2, 2, 2, and 2. Okay? And that is the final function for this transformation.